We have another truss structure that has counters in it, and so there's no joint here. These aren't connected where they cross here, but these are uh, complete members here that run all the way across. And just like in the previous two problems, we're asked to figure out what the tension in these counters are, knowing that they cannot be in compression. So what I did here is I first just looked at the entire body as a whole to figure out what these reaction forces are. So we have external loads acting here and here, and they are not equal to one another. So we need to sum them up, and so we don't have symmetry here. So these aren't all equal, so we don't have symmetry. So we can take a force balance in the vertical direction, and then some moments about point A here, and we'll get two equations for our two unknowns, FA and FH, and we find that FA is 12 kips and FH is 15 kips. So now we can cut the structure, and we're asked to find what the counters, what the forces in the counter in the in this section are here, and then also in here. And what we find is that if we write the force and moment balances for this section, okay, we get this, and again we get four unknowns here, but only three equations. So we can assume, let's say that FBE is 0, and what we find is that FCD is then negative. So that's not correct. So let's assume FCD is 0, and we get that FBE is then 10 kips. And we also get the reaction forces in these two members. And again, we should expect these to be in compression and these to be in tension, which is correct. And now if we move down to, if we move on to the next section and cut it, then we know that this one is the only one that has a positive load in it. So this one is still here, but it is not contributing, carrying any load. So in this case, we find that this one is 0, and this one is 5 kips. And so these are all in kips. So that's 5 kips, and we can see that it's a little less than this one. And again, this is compression up here, with the same amount of compression, but a little more tension in this member here. And so then we want to figure out what the force in this member here. So what we can do is we can make a cut through here, and now we know which ones of these we can neglect. We can neglect the two, this one. So basically these two are the ones that have a load in them. So we have our so when we cut this here, you know that FDG is 0. So we know that this one is 0. So then we can do force and moment balances, knowing that we know all of these loads here, and we can figure out what this one is, and we find that that one actually is carrying 0 tension, or 0 load.